In this video, we are gonna solve this problem 13 of AIME 2 2022. We are gonna work on 4 ideas and I leave 2 homeworks. And if you want to learn 40-50 important ideas and formulas in each topics, combinatorics, algebra, number theory, and geometry, feel free to send message to my WhatsApp number in the description. AIME 2 2022, problem 13, where is a polynomial, there is a polynomial p of x with integer coefficients such that p of x equals x to the 2310 minus 1 all to the power of 6 over x to the 105 minus 1 times x to the 70 minus 1 times x to the 42 minus 1 times x to the 30 minus 1 holds for every x from 0 to 1. Find the coefficient of x to the 2022 in p of x. Okay. For solving this problem, first we should pay attention to the relationship between 2310 and 105, 70, 42, and 30. So let's prime factorize this number. 0 is 2 times 5, okay, times 231. So it will be 2 times 5. 231 is what? 231 is multiple of 3, sum of the digits. 3 times 70, 21, 7. Okay? And then we can write it as 2 times 3 times 5, and 77 is 7 times 11. Okay? 105 is what? 105 is 5 times 21. So it will be 3 times 5 times 7. 70 is what? Is 2 times 5 times 7. 42 is what? Is 6 times 7 or 2 times 3 times 7. And last one, 30 is what? 30 is 2 times 3 times 5. Okay. If you pay attention to prime factorization of these numbers, we will see that 2310 is multiple of all these numbers. Okay, so this power is multiple of this one, is multiple of this one, is multiple of this one, and multiple of this one. And it is important. Why? Because of an important and basic identity. The identity is what? Ideal 1, a to the n minus b to the n equals, you can factorize, a minus b times an minus 1 plus an minus 2b plus n minus 3b squared. Powers of a are decreasing by 1, powers of b are increasing by 1. To the last one, second last one is a times b to the n minus 2 plus b to the n minus 1. Okay, now that we know, for example, a squared minus b squared will be what by this? It will be a minus b times a plus b. And also a cubed minus b cubed is what? Is a minus b times a squared plus ab plus b squared. And so on. Also, we have an identity related to these 4 plus. So first identity is this. Now we want to use this. So as you can see, for example, I want to find the relationship of this and this. I want to say this one is multiple of without 6. It's multiple of this one. How I can say that? I say, okay, x to the 2310 minus 1 and x to the 105 minus 1. I want to find the relationship. Okay, so x to the 2310 minus 1. I want to use this identity and one factor. I want to write one factor as this. I know that it is x 105 to the power of what minus what? 2310 and 105. We have 357, 357. So 2 times 11, 22. So it will be 22 minus 1 to the 22. Now we can use this identity. Okay, so we can write it as x to the 105 to the 2221 plus x to the 105 to the 20 plus, and because 1 to the power of anything will be 1, we can write it like this, plus 1 x to the 105 plus 1. Okay, so we have same factorization for other numbers. Let's write. And why it is important? Because I can write p of x as what? I can write p of x as x to the 2310 minus 1 over x to the 105 minus 1 times that it will be this. Sorry. Here, when we factorize, let me minimize it. It will be x to the 105 minus 1, okay, times this one. Now, so when we divide this by this one by this one, it will be exactly this. So this part equals this part. Okay, now for other terms, we can do the same thing. X to the 2310 minus 1 over x to the 70 minus 1 times x to the 2310 minus 1 over x to the 42 minus 1 times x to the 2310 minus 1 over x to the 30 minus 1. Now, here it is to the power of 6. We have 4 from that. So it will be x to the power of 2310 minus 1 times x to the 23. 2 will be left minus 1. Okay, so we have this. Now use this identity, the identity I've told you here, use that and write all of them like this and try to find coefficient of what? X to the 2022. Try this part first on your own. Okay, for next one, x to the 70 minus 1. If you write x to the 2310 minus 1, x to the 70 to the power of what? Let's check it here. X to the 70. For 70, we have 257. Here, 257. So 3 times 11, 33. So it will be 33 minus 1 to the power of 33. We can write 1. It will be x to the 70 minus 1 times x to the 70 to the power of 32 plus x to the 70 to the power of 31 plus 2 x to the 70 plus 1. Okay, now if we write for 42 minus 1 for this part, it will be x to the 2310 minus 1 equals x to the 42. To the power of what? Let's consider now 42. So 42 has 237, 237. What is left? 5 times 11, 55. So it will be 55 minus 1. So it will be what? It will be x to the 42 minus 1 times x to the 42 to the power of 54 plus x to the 42 to the power of 53 plus 2x to the power of 42 plus 1. And last one, if we want to consider, last one is over x30 minus 1. X to the 2310 minus 1 equals x to the 30. Let's see, it will be to the power of what? 3235. Okay, 235, 7 times 11, 77. 77 minus 1 equals x to the 30 minus 1 times x to the 30 to the power of 76 plus x to the 30 to the power of 75 plus 2 x to the 30 plus 1. Okay, now we can write p of x by using these four equations. It is what? For the first one, we can copy each of them. X to the 2310 minus 1 over x to the 105 minus 1 will be this. Okay, so the first bracket, the first fraction will be this one times second one. 2310 minus 1 over 70. So we can write it as this one times Next one is what? 2310 minus 1 over x to the 42 minus 1/3 part. So it will be this one times this minus 1 over x 30 minus 1, which will be what? Which will be this one. Control C, which will be here. Times what? X to the 2310 minus 1 times x to the 310 minus 1, okay? Now we want to see coefficient of x to the 2022 minus x to the 2022 is what? Okay. So because we want to find, and here we don't have any fraction, we want to find a coefficient of x to the 2022. So here we cannot select x to the 2310 because then the power will be added by something else. So it will be greater than 2022. So we can only use negative 1 here. Okay. So we can erase these parts and instead of them write negative 1 times negative 1 will be 1. So we can erase completely this part. Okay. Now let's focus on this. Suppose here it is 105 to the power of something. Okay. And we know the last one you can check is greater than 2022. Why? Because we know 105 times 22 was what? 2310. So when we have 105 times 21, it will be 105 times 22 minus 1, which will be 2310 minus 105. Okay? 2310 minus 105 is what? Is 2210 2205. Okay, 2205. So it will be greater than this. Okay, so here some of them are greater than this, some of them are less than this, but the first one, the power of first one is greater than this. Also, you can say the power of this, the power of this, the power of this, the power of each of them will be greater than 2022. Now we want to find what? We say, okay, suppose, for example, we select A x to the 105 to the a here. The last one is to the power of 0. Okay? X to the 105 to the power of a times x to the 70 to the power of b. We want to select some of them to reach 2022. X to the 42 to the power of c times x to the 30 to the power of d equals x to the 2022. We want to find an ABCD are what? ABCD are at least 0, and we don't need to say it is at most one what, because we know the greatest power is greater than 2022, so we can select any power here. Now we can conclude what the powers are equal. So left hand side is what? X to the 105a plus 70b plus 42c plus 30d equals what? X to the 2022. So we can conclude what the powers are equal. So 105a plus 70b plus 42c plus 30d equals 2022. Now, we know that this one is even, this one is even, this one is even, and this one is even. So all terms are even except one. So that one is even. Also, this idea was useful in AMC 10B 2023. Okay, one problem of that could be solved with this homework one. It was a problem A over something that for when you multiply, it was, for example, 14A plus 15B equals C. The problem was this, but at first it was, for example, A over 15, something like this, plus B over 14 equals C over 210. Okay, if you want to know exact problem is what or want to learn more ideas, feel free to send message from our WhatsApp number in the description because the ideas are repeated every year. So here even. So this one should be even. So A is even. We can write it A as 2A prime. Okay, so when we write 105 times 2A prime plus 70B plus 42C plus 30D equals 2022. Now we can divide both sides by 2. If we divide both sides by 2, it will be 105a prime plus 70b will be 35b plus 21c. 30 divided by 2 is 15. 15d equals 10, 11. Now, the next number that we can divide is what? We can say it is, try to find it first on your own, pause the video. We know this one, multiple of 3, multiple of 3, multiple of 3, multiple of 3. 3 divides this one, 3 divides this one, 3 divides this one, 3 divides this one. We can call it as idea 2. When you have many terms, for example, x1 plus x2 to xk equals, for example, y1 to yn. And for example, a divides x2, a divides xk, a divides y1, a divides yn. You can take all things to right side except x1. Right hand side will be multiple of a, so left hand side also multiple of a. A divides x1. Obvious idea. So we can conclude what here? B is multiple of 3, so we can write b equals 3b prime. So I can write 105a prime plus 35 times 3b prime plus 21c plus 15d equals 10, 11. Now we can divide both sides by 3, so it will be 3, 15, 5, 35 a prime plus 35 b prime plus 7c plus 5d equals 3, 11, 3, 21, 7. Okay? Now in next step. We know this one is multiple of 5, multiple of 5, multiple of 5, but this one is not multiple of 5. Here we can do what? We can consider general form of that. We can consider mod 5. So if we consider mod 5, left hand side will be 7c because all other terms are multiple of 7, right? Multiple of 5. Right hand side will be 337 mod 5. And then 7 mod 5 is 2, so 2c 337 mod 5 is 2 mod 5. Now we can divide both sides. Again, another idea in number theory. If AB is congruent to AC mod M and you want to divide both sides by M, you can divide, but it is equivalent to what? Instead of M, you should write M over GCD of M and A. Okay? Now, for example, here, M is 5, A is 2. I want to divide by 2, so C is congruent to 1 mod what? 5 over GCD of 5 and 2. GCD of 5 and 2 is 1. So it will be mod 5. So we can conclude C will be what? C is 5, C prime plus 1. So we can replace 35A prime plus 35B prime plus 7 times 5C prime. 7 times 1 will be 7. I subtract both sides. I subtract 7 from both sides, so it will be 330. Okay, and in all parts we can say by the definition we know A, B, C, D are greater than or equal 0, so A prime, B prime, and C prime are greater than or equal 0. A prime, B prime, C prime, and D greater than or equal 0. Okay, now we can divide both sides by 5. It will be 7A prime plus 7B prime plus 7C prime plus D equals, you should divide it by 5. It will be 66. Now, you can guess here we should consider mod what? Mod 7 because 7, 7, 7. So, D mod 7 should be equal to 66. Because left hand side is D, right hand side is 66. 66 is what? 63 is multiple of 7. You can subtract, it will be 3 mod 7. So, we can conclude D equals 7D prime plus 3. So 7A prime plus 7B prime plus 7C prime plus 7D prime plus 3. 3 we can subtract 3 from both sides, 63. And again D prime also at least 0. A prime plus B prime plus C prime plus D prime equals 9 if we divide both sides by 7. And A prime, B prime, C prime, and D prime are at least 0. Okay? Now let me tell you how you can solve these types of problems. It will be idea. Idea 4 is, what is that, for example? When you want to solve x1, x2 to xk equals n, if it is xi's are at least 0, it will be n plus k minus 1. Choose k minus 1. Now let's see the reason is what. For example, suppose x1 plus x2 equals what? Equals, for example, n. Okay, so for example, or equals 10. We can say we have 10 balls. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I use one divider. Okay, for example, here. Then this one will be x1, this one will be x2. Okay, so this divider can be here, 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 and this one. 11 cases. So the answer will be 11. If we use the formula, or we can say what? 11 choose 1. Okay. And here n plus k, n is 10. It will be 10 plus 2 minus 1 over k minus 1. 1 is 11, choose 1. Now let's solve a bit harder. For example, x1 plus x2 plus x3 equals what? For example, 7. And xi's are at least 3. At least 0. 3, 4, 5, 6, 2, 4, 6, 7. Okay? Now here we can say, okay, I need how many dividers? 2 dividers. Okay? For example, here, here. This one will be x1, this one will be x2, this one will be x3. So I want to find all permutations of 7 balls and 2 dividers. So how many objects are there? 9 factorial permutation with repetition. 7 from same thing, 2 factorial. So it will be 9 choose 7 or 9 choose 2. Okay, now we can prove why x1 to xk equals n will be that number. x1 to xk equals n. You say, okay, how many balls are there? N balls. How many dividers are there? You can say, okay, we have 1 divider, 2 k minus 1 dividers, then you have k parts. So the permutation will be what? How many permutations are there? N plus k minus 1 factorial over, we have n balls and factorial k minus 1 factorial. Or we can write it as n plus k minus 1 choose n, or n plus k minus 1 choose k minus 1, which is exactly this one. Okay, now we want to solve this. You say, okay, n is what here? N is 9. K is what here? K is 4. So n plus k minus 1, 9 plus 4 minus 1. Choose k minus 1, 4 minus 1. Because we have 9 balls and 3 dividers. Okay, so it will be 12 choose 3. Okay, 12 choose 3 is what? Is 12 times 11 times 10 over 3 factorial. 3 factorial is 6. It will be 222, 220. Okay, so we've worked on 4 ideas, and I told you one homework here. Let me tell you another homework. You can also try this one, AMC 12A 2022, as homework 2. If you want to solve more problems, want to work on more ideas, 40, 50 important ideas in combinatorics, algebra, number theory, and geometry that are useful in AIME, AMC, USAMO, USA, JMO, IMO, feel free, or any math exam, feel free to send message. My WhatsApp number in the description.